Courtney Ostaff, and I teach math, science, and history here at the Well-Trained Mind Academy. I've been teaching online for a long time. In fact, since the year 2000, including college algebra from 2006 to 2013. In fact, I enjoy teaching so much. I went back to school and got another master's degree in it. And so now I have a master's degree in secondary education and a certificate in special education. And now I'm certified and licensed to teach social studies, general science, math, and students with visual impairments from birth to adulthood. I have a lot of experience in working with students who have some learning differences or who are neurodivergent in some way or another. I really enjoy teaching math because I think of it as an opportunity to bloom. Students often come to me who don't necessarily really enjoy math, and hopefully by the end of the year, I make them feel more confident. So in my classes, generally speaking, I offer breakdowns of assignments by week, and I offer a daily list of assignments. So every day, generally speaking, you're going to have some homework. On Mondays, you're going to answer discussion questions. Every Wednesday, you should be responding to two other students. And I generally have a lighter day on Friday when we have an assessment. Now, math classes that I teach generally meet twice a week. So science classes that I teach generally meet once or twice a week, and social science classes like world geography generally meet once a week. So on those before class, before you come to the live class, you should read your assignment, do any assigned homework, prepare any notes. And during class, we generally focus all together, and I will be constantly asking questions and expecting you to answer. I'd use a lot of polls. And then after class, I'm usually on Friday, I offer some assessment. Now, notice all of this takes place during the week. While I do try really hard to provide all assignments 2 weeks in advance so that families can arrange their schedules as best suits them, I try really hard not to assign things on the weekends so that students have time with their families. They have a couple days that are fully off. So I hope that you're feeling kind of confident about how my classes are arranged. Let's go ahead and, well, do a lesson. So I'm going to share my whiteboard right now. There we go. And let's talk about squares and square roots and how they work. And I like to work from first principles. So let's talk about this. What is that? If you answered that it is a point, you would be correct. In math class, it's a point. And what is a point? Well, a point is sort of, in a way, a figment of our collective imaginations. All over the world, math students learn about points and they learn that they don't have any size. They're not anything that you can touch, you can't pick them up, you can't hold them, and you can't really measure them. They don't actually exist. But if you take points and you string them along like a bead, like that, you have made a line. Yes, you have made a line. So if a point doesn't really exist, it doesn't have any dimensions. It has what we call zero dimensions. But a line has how many dimensions? Do you know? Yeah, it has one dimension. And what are we measuring when we measure lines? What are we really measuring there? That's right, we're measuring the length of it. We're measuring the length of the line. So if I have two lines, one here, and I'll draw one sort of catty corner to it right there, I have created something else. Do you know what that thing is called? Any two lines make a plane. A plane. And because there are two lines, and remember, lines are made out of points. And so because points don't have any size, there you can squeeze as many of those things in. You can squish as many of those things in there as you want. And in sort of in reverse, lines theoretically go on forever, which we indicate by those little arrows. And so because lines go on forever, so does a plane. So a plane is kind of like an infinite sheet of paper that is infinitely thin because remember, lines only have one dimension, that length dimension. So a plane only has two lines, two lengths. And so how many dimensions does it have? It has two dimensions. Now, here's where it gets interesting because we know, of course, that you can measure any given line, right? We can measure the length of it. So I can go, it's one, it's two, it's three long, for example. And then I can go to the other line and I can go, well, that's one, that's two, that's three long that way. Now, this is interesting because I have made a whole bunch of little itty bitty squares, squares. And so what do we call this thing that we have gridded out into squares? It's the area. If lines are measured in length, planes are measured in area. And this is true for all kinds of planes. So if you go to the store and you buy yourself a ream of paper, that paper in the United States is going to come 8.5 inches long on one side and 11 inches long on the other. And if you tried to measure the area of that paper, it would be so many square inches. Now, I live out in the middle of the woods, and there is a pond on the other side of the hill. And somebody says, well, how big is the pond? I would probably tell them it's so many square feet, surface area, so many square feet. Or, I have a house, and the house is on a piece of property, and we measure the property in acres, which is a square measurement of so many feet by so many feet. And so on. And you can get really big, square hectares and so on. And you can get very, 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 very small. You could have square inches or square centimeters or square millimeters or even square nanometers. So planes are measured in squares. And so that's really very interesting because if I gave you, if I gave you a problem and I said that it was three this way and three this way, you could, in fact, you could count 1, 2, 3, 4, 5, 6, 7, 8, 9. You can literally count how many little squares there are. Or, or you could sort of be more efficient about it and say, well, I have one row of three, two row of three, three rows of three, three threes. Well, what's three threes? Yeah, it's nine. Three threes is nine. And so, of course, mathematicians are always trying to find like more efficient ways of doing things. And so instead of writing three threes, we might write this like this with an exponent. Now, one of the interesting things about this exponent is instead of saying all the time that it has a base of three, so the three is the base, you may remember that from a previous lesson, and the two is the power. So instead of reading it as three to the power of two, we might instead say that that is three squared. And so why do we say it's three squared? Because we're literally measuring how many little squares we would make. So that two then becomes three squared. Now we can go back again and we can take our plane. So, try and do a little better drawing right here. One this way and one this way. And then, what happens? What happens if I take another line that is at a 90-degree angle to them both, and I run it out that way? How many lines do I have? I have three lines, so how many dimensions do I have? That's right, I have three dimensions. And I can measure it, though, pretty much exactly the same way. I can say, well, this one is 1, 2, 3 long, and this one is 1, 2, 3 long. But I can also go to that cat corner line and I can say that that one is 1, 2, 3 long. And so I can sort of match it out here and I can come around to the back and I can draw it like this, bring this out like so. And do you see what's happening here? And if I measure this out, that it's 3, I bring this up like so, and I bring this one up like so, and then I take it across like this. I have measured a whole bunch of, and here, let me draw one clearly and distinctly, just one little individual, itty bitty, teeny tiny little, yeah, it's a cube. And so what's really interesting is that if planes are measured in squares and we call that area, then this thing that I've drawn here is measured in cubes, and we call that the volume. The volume. So this 3D shape, we can measure it by the volume, and the volume is measured in cubes. And so that's true of all kinds of volume. So for example, if I have a loaf of bread, I could say that the volume of it is so many square inches. Or if I have, maybe I'm making a casserole and I get out my 9 by 13 casserole dish, but it's 2 inches high, so I can say that it is 9 by 13 by 2. That gives me so many cubic inches in that casserole pan. And so that's the other thing. Whereas area is measured in, say, 3 squared, let's see how big, our 3D is. So remember, it's 3 this way, and it's 3 this way, but it's also 3 this way. So that very first row right there, uh, let me do a different color here. That very first row right here is, of course, 9 little cubes, right? 9 little cubes right there. But then the second row is also 9 little cubes. It's exactly the same, but behind it. And the third row is also 9 little cubes. So let's think about that a minute. I have the first row of 9. I have the second row of 9, and I have the third row of 9. So if we think about that for a second, we can think about that and we can say it's 3 by 3 by 3. Meant that to be black. Let me change the color there. A little easier to read. 3 by 3 by 3. And which is the same thing as saying I have 9 plus 9 plus 9. Each row has 9. And 9 plus 9 plus 9 is 27. But also 3 times 3 is 9. And 9 times 3, well, we just said was 27. So when I have this 3 times 3 times 3, just like 3 times 3 is 9, it's squared, 3 times 3 times 3 is 3 to the third power, but we don't call it that. Very often, we'll say that it is 3 cubed because we literally made 3 little cubes out of it, which is kind of neat. So that's why we say something is 3 squared or why something is 3 cubed. And hopefully you feel a little bit better about why that is so. Thanks for coming. I hope you enjoyed the lesson.